Alright, here we go. A report about how American college students manage their finances includes data from a survey of college students. Each person in a representative sample of 793 college students, N equals 793, that's the sample size, was asked if they had one or more credit cards, and if so, whether they paid their balance in full each month. There were 500 who paid in full each month. For this sample of 500 students, the sample mean credit card balance was reported to be $825. The sample standard deviation of the credit card balance for these 500 students was not reported. But for the purposes of this exercise, suppose that it was $195. Is there convincing evidence that college students who pay their credit card balance in full each month have a mean balance that is lower than $905? The value reported for all college students with credit cards. Carry out a hypothesis test using a significance level of 0.01. So let's state all of the information we have. This kind of threw us off. We don't need this. Actually, yeah. So that's just a little bit of trickiness. Actually, let me just erase it. They tried to throw us off by including that unimportant statistic. Here we have n equals 500 because that is the sample who paid in full. That is that is the population or the sample we are testing. The sample mean balance was 825. By the way, I did used to write my 8s like this. I recently did change to this. The sample standard deviation, like it said, was not reported, but we can, for the purposes of the test, we can assume it was $195. So the question is there convincing evidence that college students who pay their credit card balance in full each month have a mean balance that is lower than 905? So that's going to be our alternative hypothesis. So our null hypothesis is going to be the mean equals 905. And the alternative hypothesis is going to be that the mean is less than 905, indicated by lower than in our problem. So let's go over here and see if our answer, there it is. That is answer 1. So we'll now solve for the t-statistic and the p-value. The equation for a t-statistic, what that just happened, is t equals x bar minus the hypothesized mean over s divided by the square root of n. As you can see, we have x bar, we have the hypothesized mean value, we have s, and we have n. So we can just fill out this equation. Typically, the sample standard deviation is unknown, so you would have to use the equation. We would first have to solve for variance, which is the sum of the difference in statistics, I guess. I don't really know how you would word that. Squared divided by n minus 1, which is degrees of freedom. And then obviously, to get the sample standard deviation, you would just take the square root, and that's the answer. Not the answer, but that's the standard deviation. Sample standard deviation. But in this case, we can just fill out this equation. So, we have 825 minus the hypothesized mean of 905 divided by 195 divided by the square root of 500. So let's go ahead and plug that in. That's going to be solving for t. 825, 905, 1955. 825, oops, 825, 905, 195, 5. Okay. We get a t-statistic of -9 And then to find the p-value, we're going to use this. In this problem, we can see that we're doing a lower tailed test because we're testing lower than 905, so it's going to be the area to the left. We're going to input our t-value, the entire t-value, no rounding. Okay, let's check our answers.